Let's talk about finding chances. On the other hand, the probability. So usually we talk about that mean each event. Yeah, something happens, some events. So anything possibly happen, they were between 0 to 100. If your chance for the event is chance of event happen is 0, that's the lowest value. That means it's impossible to happen. So what is impossible happen? For example, I put 10 red color ball in a bag. Then I say I want to draw a white one. You see, because there's no white ball in the bag. So that's impossible happen. Okay? So then you have highest value is 1. So the chance of event that's certainly happen. Like earlier I said, I put 10 red color balls in the bag. So then I say I will draw a ball, the color is red. Yeah, because I only have red color, so of course I will draw red color. Okay, so that's the differences between the 0%. We say the chance for an event to happen is 0 to 1. 0 is impossible because they are not there. Okay, 100% that's mean. Yeah, everything there is the impossible happen. So that's the fundamental definition for the probability for certain events. And also we have another terminology we call complement. If an event has chance 70%, then the chance it does not happen, we call the complement events. So then you just need to do is 1 minus the chance the event will happen. Because they either happen, they are either not happen. So you cannot do either or. Okay. So then one event happen and one event not happen, total chance is 100%. So the complement event always is 1 minus chance the event will happen. So the 70% will be 1 minus 0.7 is 0.3. So we talk about probability all the time, but the most important thing we assume, we call that equally likely outcomes. We assume all outcomes are equally likely. The chance of event A is equal to the number of outcomes that make A happen divided by the total number of outcomes. So we need to remember everything the outcome are equally happen. For example, in the previous lecture, our example review for lecture 13, we give you another example simulation. We want to toll 100 coins, right? So no matter 100 coins or 1 coins, you flip the coins, the result either head or tails. They are equally likely happen. Cannot prefer any one of that. So that's why sometimes the same thing with rolling a dice. So that's why we say sometimes people cheat, right? They do the gambling if they change to use a special dice. That's not regular probability. So that's why we say here the equally likely outcome is we assume that happens. Suppose they should happen. Okay. So from this definition is important number of outcomes that make A happen. So what is the A? For example, you say you're rolling 2 dice, the total is 7. So then we say A just total equal to 7, right? So then your combination can be 1, 6, can be 2, 5, can be 3, 4. So that's mean the number of outcomes. So you need to include all the possible outcomes you say the A. So to be total 7, you have different outcomes. Then the total number of outcomes is what? Earlier we say we rolled 2 dice. So that's why the total number of outcomes is all the combination after you roll 2 dice, what their outcome is. They can be 1, 6, 2 and 5, 3, 4, and 4, 3, or 6, 6, or 1, 1. They have many all different outcomes, so you need to consider. So that's why let's think about this question. I told you I have 3 cards. I have Ace of Hearts, King of Diamond, Queen of the Spades. And we just say you can forget about the suite. We just using we have Ace, King, and the Queen. Yeah, of course they have exactly 1. So that's why we give you the what count it is. We shuffle them randomly. Then we say we draw 2 cards. Okay, two cards at random without replacement. So what is the chance I get queen followed by the king? Okay, so pause the video, then I will show you. So the most important thing, think about the definition we have. So the number of outcome make king first and the queen, then divide by total two cards combination. Okay, so we see all the possible outcome, right? Because they say get the queen followed by a king, so we only have one combination, king first, queen first and king. Okay, but between the ace, king, and the queen, we have so many combinations, right? We can be ace first, then king, or ace first, then queen. Okay, or we have king first, then queen, or we have king and ace, then we have queen or ace, or queen and king. So that's why total you have 6 different outcomes, but only one, that's what we want. So then that's why your result will be 1, 6, because that's the total number of outcomes. Then you only have one combination for the queen, then followed by king. So that's 1 of 6. So that's one way to think about that. So using all the possible outcome as a denominator, then the numerator is the outcome for what we are looking for. So that we get queen followed by the king. But then also we can think about the other way. Okay, so this way we talk about is multiplication rule. So multiplication rule is what? It's the chance two events A and B both happen. So we think about this one again. You get the queen followed by the king. That's me. I need to have first one is queen, right? Good. So if the first one is queen, what is that? So first one is queen, actually is 1/3, right? Because when you want to draw the first one is queen, you have 3 cards. So queen is one of that. So 1/3. So then followed by the king. So since you already have queen, then you only have 2 cards left. So then that need to be king. So either king or S, right? So the second one is king is 1/2. So they follow by, so and they are what? The first event happened and the second event happened. So then we multiply. So that's equal to 1/6. So that's the same as earlier we showed you. So this one is we call multiplication rule. The chance that two events A and remember and B both happen. So we use the chance for the A happen times B chance or B happen. But of course, because they need to have the B happen given by the A has happened. So this one we call that conditional event. A need to be happen, then B. But on the other hand, I like to think is they are and, A happen and B happen. That's the multiplication. You always remember, you feel like and, it's multiply. So that's why earlier, queen is 1/3. King is 1/2. Yeah, why king is 1/2? Because queen already been drawn. So we only have 2 cards left. So then we multiply this. So the answer is less than or equal to each of the chance because they multiply. So they won't be greater than either of that. The more condition you have to satisfy, the least like you are satisfied than all. Okay, so one thing is, you see, when you have so many conditions, A and B and C and D, yeah, so actually sometimes their chance at the end will be smaller because you continue to multiply under than 1 or equal to 1. So after the multiplication rule, let's see another question. We still have these 3 cards. So this time we are not saying queen first and king. We just still have the even likely chance. So what is chance? One is king and the other is queen. Again, don't forget, we're still drawing 2 cards. So we still can using two different approach. So the first one, we see the O combination, right? So here is O combination. But now we just say you join two cards, you have 6 combination. So one is king, the other is queen, right? So on the other hand, that's mean one is king, the other is queen. You can be the first card is queen, second card is king. Or the first card is king, second card is queen. So that's why, that's different than earlier. So here, you have one is king, one is queen. You have 2 combination. Divide by total, you have 6 combination. So 2 out of 6 equal to 1 out of 3. Okay, so that's the king and the queen. So this way is we use the thing, we're using the definition for the P of A, number of outcomes that make it happen. So king and the queen, right? So they are no order, so that's why we have 2 combinations. So that's why we have king and queen, so that's why 2 out of 6. So the other way we can think about is what? So then we can think about, in order to have, I got the 1 king and 1 queen from that 2 cards, I have either queen and the king or king and queen. So either one, you see, this one is 1 out of 6. Okay, so this one is 1 out of 6. So 1 out of 6 plus 1 out of 6 equal to 6 out of 2 out of 6, so it's 1/3. So that's why you have different approach. A lot of time we're using the definition about the how to find the outcome for the chance of the event. Or we have the first one, we talk about multiplication rule. Then this one actually is the second rule, we call addition rule. So addition rule is what? If event A happily have exactly, here it's not really exactly 1 or 2, we just say if they have 2 different ways. So one thing you can say is event A can happen is in multiple ways. So to make event A happen, you just need to add them together. So in our example, this one king, 1 queen can be king first, then queen, or queen first, then king. So that's 2 different ways. Okay, so then we add them together. So when you add them together, the answer is greater than or equal to the chance of each individual way because addition. But here, one thing is remember, they are not only have 2 different ways. Okay, so they maybe have multiple ways. Then you just need to add all the possible outcomes for event A. So that's the one complement question. So this question is, we will roll 4 dice together. At least, what is chance we get at least 1/6? Yeah, pause the video, you can think about that. Yeah, so roll 4 dice, then we get at least 1/6. We can see one thing, right? And by definition, we can list all the possibility. You can be 1/6. You can be 2/6, 3/6, or 4/6. So 1/6, you see this 6 can be in 4 different positions. If the 2/6, yeah, you see if 2/6, you can do like, actually they have more combination. I want you to play with that. Okay, you can do this way. Okay, you can do this way. Okay, so actually many. Okay, so I will show you later. So then, or it can be 3/6. Okay, so then this n can be in different location. Or you have 4 are all 6. So on the other hand, actually you need to fill up all the combination. For here, if we just do the 6, 3/6. Okay, so that's the combination because you just have your n in different place. Okay, so then like this. Okay, but this we can't finish, but this one we didn't finish. So each one, they are 1/6. Actually, they are 1/6 power to 4. But actually easier to think about this question, like we say, you can show all the combination, then you add n together. Each one, they are 1/6 to the power of 4. But since we told you at least 1/6, what does that mean? That means all the combination minus